26,000 light years away. You've been doing this your entire life. Your parents did it. Every ancestor you've ever had. Every human who ever lived. Every star you've ever seen in the night sky. All of it. 200 billion stars, gas clouds, planets, everything in the Milky Way. Moving in vast, patient orbits around the same invisible center. At that center sits a supermassive black hole, 4 million times the mass of the Sun. And for most of human history, we didn't know it was there. Tonight, we're tracing the story of Sagittarius A star, the invisible center of everything we know, the dark heart of the Milky Way. Let's begin. For thousands of years, people looked up and saw the Milky Way as a band of light stretched across the sky. Faint, diffuse, beautiful, but just light. By the early 1900s, they understood what it was. A galaxy. Spiral. Vast. With us off to one side, about 2/3 of the way out from the center. We assumed there was a center, some dense region where starlight pulled. But we thought it was just more stars, closer together, brighter. Nothing special. The problem was visibility. Between us and the galactic center, enormous clouds of gas and dust block optical light completely. When you look toward Sagittarius with a normal telescope, you see nothing but darkness. For centuries, the center of our own galaxy was hidden. Then, in the 1970s, radio telescopes began scanning the galactic center. Radio waves passed through dust, and they found something strange. A powerful, compact radio source. Bright, concentrated, unmoving. Too bright to be starlight. Too small to be a star cluster. Too concentrated to be gas. They named it Sagittarius A star, after the constellation where it appeared in our sky. Something massive was there. Something invisible, pulling everything toward it. But you can't see a black hole. You can only see what it does. In the 1990s, two teams of astronomers began one of the most patient experiments in the history of science. Keck Observatory in Hawaii, the Very Large Telescope in Chile, both aimed at the same patch of sky, the galactic center. Using infrared cameras, watching in wavelengths our eyes can't see, they tracked individual stars near Sagittarius A star. Not hundreds of stars, a few dozen. Year after year, image after image, watching them move. And the stars moved fast, not the slow drift you'd expect from distant objects. These stars were whipping around something invisible, like planets around a sun, but far more extreme. Tight orbits, elliptical, violent, bewilderment. One star became the key, a blue-white star, unremarkable, except for where it was and how it moved. The teams called it S2, and S2's orbit what prove everything. S2 orbits Sagittarius A star every 16 years. That's extraordinarily fast for something orbiting the center of a galaxy. Our Sun takes 230 million years to complete one orbit. S2 does it in 16. At periapsis, the point where S2 comes closest to the black hole, it gets within 17 light hours of Sagittarius A star. Neptune is about 4 light hours from the Sun. S2 gets that close to a black hole. And at that distance, it accelerates to about 2 to 3% the speed of light, around 7,000 to 8,000 kilometers per second. Fast enough to cross the distance from Earth to the Moon in less than a minute. Scientists followed S2 for decades, tracking its motion year after year. They watched it sweep past the black hole in 2002, and again in 2018. One full 16-year orbit, from close pass to close pass, and the next orbit is already underway. Frame by frame, year by year, they could see it accelerate as it approached periapsis. They could see it decelerate as it moved away. The path was perfect, Keplerian, exactly what you'd expect from an object orbiting a massive point source. And they did the math. To make a star move that fast, in an orbit that tight, there has to be something incredibly massive at the center, concentrated in a space smaller than Mercury's orbit around the Sun. The numbers were precise. Roughly 4 million solar masses. No star cluster could be that dense without collapsing. No gas cloud could stay together under that kind of gravity. No normal object could hide that much mass in that little space. Only one thing fit the evidence: a supermassive black hole. By 2002, the case was closed. Sagittarius A star wasn't just a radio source. It was a black hole. Our black hole. For decades, we knew it was there. We could measure its mass, track stars orbiting it, map its gravity, but we'd never seen it. In 2019, the Event Horizon Telescope, a planet-sized network of radio dishes working together, revealed the first ever image of a black hole. M87 star, at the center of a galaxy 55 million light years away. A glowing ring, a shadow, proof. And then, in May 2022, the EHT released a second image, this time closer to home. Sagittarius A star. It took longer than M87 star, because Sagittarius A star is more difficult to photograph. M87 star is massive and stable. It changes slowly, over days or weeks. Sagittarius A star is smaller, and it flickers. Gas swirls around it, on timescales of minutes to hours. Brightness shifts constantly, like trying to photograph a child that won't sit still. While the child is also 26,000 light years away. But the teams synchronized data from telescopes across the planet: Chile, Hawaii, Arizona, Mexico, Spain, and the South Pole. Multiple observatories, working as one, combining signals.